Okay, so we are going to talk about the problem 15 from the chapter 2 of Halliday's book, 9th edition. Okay, so let me write here is the problem number 15 of chapter 2. So the question, there is a sequence of questions. No? It starts like this. For part A, we have a particle and the position of this particle is given by this equation. So x is equal to 4 minus 12t plus 3t squared. T is in seconds and x is in meters. So the first question, part A, is what is the velocity at time t equal to 1 second? So what is the velocity at time equal to 1 second? Okay, so first thing we have to do is do the derivative of x to get the equation for the velocity. So let's do that. The derivative of x will give us 4 is a constant, it disappears, and we'll have minus 12, and then 3t squared will have plus 6t. Okay, so this is the equation for the velocity. If we want to find the velocity at time 1 second, we substitute this time, and then we'll get this velocity, which is going to be equal minus 12 plus 6 is going to be minus 6 meters per second. Okay, so this is the velocity. And then comes the question, is it moving in the positive or negative direction of x? Well, if we have a minus sign, that means part B, we are moving in the negative direction. So we are moving in the negative direction. Very well. Let's see what is the question in part C. What is the speed? Well, speed we know is the magnitude of the velocity, so that is easy. The speed, I'm going to write here, the speed is just the magnitude of the velocity, and this means then 6 meters per second. It's just the number. Then comes the next question. Is the speed increasing or decreasing at this point, at this time? Well, how can we know that? Well, we have to find what is the direction of the acceleration, right? If the acceleration and the velocity have the same direction, we know that the object is speeding up. If the acceleration and the velocity have opposite directions, then we know that the object is slowing down. Okay, so let's try to find out the acceleration. So I'm going to answer this question E. To answer this question D, I'm going to try to find out the acceleration, which is the second derivative of the position, so is this the first derivative of the velocity. And what we find that this acceleration is then 6 plus 6 meters per second squared. So the acceleration is positive. And what we found was that the velocity here was negative, right? So since the acceleration is positive and the velocity is negative, we know that the object is slowing down. So the speed is decreasing right at this point at time 1. Okay, then, so this is part D. Part E is there ever an instant when the velocity is 0? Well, that we just need to go and look at the equation for the velocity. This equation here that we found for the velocity, well, let's look at that. Is there an instant where this velocity is 0? Well, is there an instant where v becomes equal to 0? For that, we have to solve that equation. Minus 12 plus 60 equals to 0, right? So then we find that at the time 2 seconds, yes, the particle stops. All right, then part F. Is there a time after time t equals to 3 seconds when the particle is moving in the negative direction? Well, again, let's look at the equation for the velocity. The equation for the velocity, I'm rewriting it here, is minus 12 plus 60. At time 3 seconds, what do we find for this velocity? Well, we see that this velocity is minus 12 plus 18, right? So it's plus 6 meters per second. So it's positive. The velocity is positive. And any number larger than 3 will keep giving us positive velocity. No? Any number, any time larger than 3 seconds will give a value here that is larger than minus 12. So the velocity after 3 seconds is always positive. Okay, so we finished this problem, but let's try to explore it a little bit more. We have this equation for the velocity, so we could try to find out for which time interval this velocity is negative, and therefore the object is slowing down, because we already found that the acceleration is positive. Now, so for which interval, time interval starting at time 0, we can answer that, right? Based on this equation and what we found here in question E, we know that the velocity is negative in this interval for t, for the time in this interval from 0 to 2 seconds. Yeah. So from time 0 to 2 seconds, we can say that the speed is decreasing, that this object is slowing down. Yeah. Now, for any time larger than 2 seconds, anytime larger than 2 seconds, that's when this term here becomes larger than minus 12. So for any time larger than 2 seconds, the velocity is positive. And therefore, and since the acceleration is always positive, the acceleration in this problem is a constant plus 6 meters per second square. We found it here. So for any time larger than 2 seconds, we know that the speed is increasing. We know that the object is speeding up. And that's the end of this problem.